Hello everyone, let us discuss today's LeetCode POTD problem. LeetCode 1574 shortest subarray to be removed array sorted. So in this question we are given with an array of length n. So we need to remove the shortest non-increasing array, or uh, we need to determine the subarray which can be empty, such that the remaining the remaining array is non-decreasing. That means can be strictly increasing or it can be equal. And then we are given with an example: 1, 2, 3, 10, 4, 2, 3, 5. Now, in this array, if we remove this subarray 10, 4, which is not increasing, so we can make the array sorted or non-decreasing array. And we are also given with another example: 5, 4, 3, 2, 1. In this we need to remove 5, 4, 3, 2 or 4, 3, 2, 1 to make the array 1 or 5. It is non-decreasing array. So we are also given with another array which is already sorted 1, 2, 3. So there is no need to remove any element. So we we make the output as 0. Here we gave the output as the output as 2. From the beginning and from the end, instead of finding the decreasing array in the middle, decreasing subarray in the middle, so we need to find the increasing subarray from prefix and the increasing subarray from the suffix. So we make prefix as 1 and suffix is also 1, and then we run two loops from the beginning and from the end. For I is equal to 1, I is less than n, I plus plus. If this element is greater than the previous element, if array of the current element is greater than array of the previous element, then we increase our prefix. Or else, if we get to the this point where for example it is 10 and it is 4, then it is not increasing, so we stop here. Else we break the loop here. Then what if we got the suffix as prefix as 1, 2, 3, 4, 5, 6, 7, like this? So in this array, the array is already sorted, so there is no need to remove any subarray which is to make the array as sorted. As it is already sorted, we return 0. The condition here is if prefix is equal to size of the array, then we return 0. Else, for I is equal to n minus 2, I is greater than or is equal to 0, I minus minus. So so we need to find our suffix from the end. The suffix array which is not strictly, which is increasing. So if we talk about not a strictly increasing but a not decreasing array, we make n is equal to sign here. So because if we have 1, 2, 2, 3, It is a subarray which is increasing. So 2 and 2, even if they are equal, they are increasing. And then here, if array of I is less than or equal to array of I minus, sorry, I plus 1. Remember, we are going from the end. That means we get 5, 4, 3, 2, 2, 1. That means when we are at 4, we need to check is it less than or equal to the next element. So is the next element, sorry, is the present element is less than or equal to the next element, then we increase our suffix, else we break the loop. So in this observation, imagine we got the suffix as the length of 8 and the length of array is 10. So what is the best case to remove is, and then for example, we got a prefix as 1 and a suffix as 8. Then you can remove 10 minus 8 to make this as increasing, or 10 minus 1 is equal to 9. 10 minus 8 is equal to 2. In these two, we can return 2 as it is the minimum subarray which we can remove from the array to make it sorted. By taking the same example 1, 2, 3, 10, 4, 2, 3, 5. The prefix we get is 1, 2, 3 and 10, and 4 is lesser than the previous element, so we stop here. This is the prefix we got, and then 3 is less than 5, 2 is less than 3, but 4 is greater than 2, so we stop here. This is the suffix and this is the prefix. So we need to return the size of the subarray, which by which we can get the array as sorted. So we run a loop where a two pointer loop where I will be considered here, and j is pointed here, j is pointed here, and I is pointed here. So we need to find the last element, or sorry, we need to find the size of the subarray which can be removed, the minimum size, the minimum length of the subarray which we need to remove from the array to make it sorted. So if array of j is greater than I, we increment our I. So we need to get to the point where we get the I as the most, array of I is the most element, greatest element, and we calculate the length for every iteration. So we get the minimum length. So I is less than or is equal to j, then we increment I. But every time we increment I or every time we increment j, for every iteration we are considering our length. Now the length is equal to, imagine the minimum length we got is from here we can calculate 8 minus the maximum from these two, prefix and suffix, is maximum of 4 comma 3, it is 4. So 8 minus 4, that is equal to 4. Up to now the minimum length we got is 4. Now the length we calculated here is, when j and I are pointing here, the length is 4. It is equal to the minimum length, so we know there is no need to change the minimum length. And when it is here, I is pointing to the first index and j is pointing here, the minimum length or the length we got is 3. So it is 3 and the minimum length is 4. The minimum from these two is 3, and then 3 sorry 3 is greater than j. Sorry. As we got I as at this index, now j is at this index. So we now calculate the size of this array. It is 2. Of this subarray, it is 2. Now length will be 2 and the minimum length from these two is 2. And then as array of I is not less than or is equal to j, we increment j. It is here, and I is array of I is not less than or equal to j, so we increment j. Array of I still is not less than or equal to j, we increment j. So j is out of loop, sorry, out of bounds, so we stop here. So we write a pseudocode while I is less than or equal to prefix. So I will be running up to the prefix and j will be running uh, up to the bound of array less than or equal to prefix, and j is less than n. If array of j is greater than or equal to array of I, we change the minimum length is equal to minimum of minimum length comma j minus I minus 1 and I plus plus. So imagine 0, 1, 2, 3, 4, 5, 6, 7. 5 minus minus 2. 5 minus 2 is equal to 3. But the length of the subarray is 2. So j minus I minus 1 will give us the correct length. Else, if array of j is not greater than or equal to array of I, we increment the j, and after all the iteration, we return the minimum length. Thank you.